Good morning, ladies and gentlemen in the USA. Good morning, ladies and gentlemen in Canada as well. Welcome to the VDW's Web-Symposia. I'm pleased being the first speaker to you today, and I would like to introduce myself real quick for you. My name is Roland Dilk, and I'm the president of ALZMETALL, family-owned foundation. And for 76 years, we serve successfully our worldwide customer base. Now, where is ALZMETALL in Germany based? ALZMETALL is based in the south of Germany, actually in Bavaria and south of Munich. Munich is famous for the Oktoberfest, so all of you guys out there will remember where we are. And basically, we are close to the Austrian border in the Alps. Our company, the key figures for our company is we have 400 long-serving employees, and year by year we occupy 10% young people at our apprenticeship, which is a dual education training program, which is basically Germany famous for. And what makes ALZMETALL famous worldwide too is the international reputation and global activities. Now, how are we represented in the US? In the US, our rep is European Machine Tools. The contact is Mr. Enzo Aita. He is the owner, and he's based in Heartland, Wisconsin. And he will help you with further questions as well. Now, in Canada, we are represented with Mitchell Machine Tools. The contact is Tony Secombe. He's the owner as well, and he's based in Toronto, Canada. Giving you a quick overview of our product range for machining centers. Basically, we have 20 types, five series, which different applications. And first of all, I would like to introduce you the easiest and simple one, which is a 3-axis model. And this 3-axis model has movement out of the 3 linear axes, X, Y, and Z. And this machine is equipped with a stationary table. The customer can choose for the rotary axis and the swivel axis for 3 different drives. So first of all, we have a swivel axis, which we call the A-axis, and a rotary axis with a gear drive. Basically, it's a 2 cycloidal gear drive for swivel and rotary axis. I think this photo is pretty much self-explanatory, and customer can choose for our 4th and 5th axis for 2 torque drives. The 2 torque drives in the A-axis in the sidewalls, which are patented for ALZMETALL, and a torque drive in the C-axis. The C-axis is a rotating table, as you can see. And last but not least, customer can choose for direct torque drives as well. And with this equipment, the customer is able to do both milling and turning at one application setup. So these are the drive options which every customer can choose before he's purchasing a 5-axis vertical machining center from ALZMETALL. Run through the product center line real quick. The smallest machine, which is our space saver GS600, we have a travel of 18-inch in X, 24-inch in Y-axis, and 400 millimeter in 16-inch in Z-axis. And the key performance indicator is the table load. You can put workpieces of 1,102 limbs on this machine. Next size of our machines is the front runner. The front runner is the GS800 new engineered series. Again, we have 3-axis, 4-axis, 5-axis torque. version, and I save time to tell you the dimensions for the axis movement, because you can help yourself and read this out. But the key element is the table load of this machine. There are options 1,100 limbs and maximum 2,200 limbs. Now, next size of our equipment is the bestseller, which we call the bestseller. It's a GS1000, and again, available in 3 to 5 axis. And here is a table load, 2,500 limbs to 3,300 limbs, which is quite considerable. And if you look at the right-hand picture, your parts can be machined with a diameter of 35 inch and a height of 20 inch. Now, next one is the GS1200. This is our heavyweight, and heavyweight is meaning that you can put work pieces on that machine with a table load of 5,500 limbs. The last one I want to introduce to you is our flagship, the GS100 1400, and it has an X treble for work pieces like 66 inch in diameter and a height of 27.5 inch. Now the table load is 6,614 limbs, which is considerable high compared in this class. I guess it's the most load you can put on a machine of this size. So that's been our product line real quick. And now I want to tell you a little bit about automation solutions. Yes, we do have robot loading systems. And if the machine is equipped with zero-point clamping system, this application you can see on the photo is a system with 70 workpiece pallets. There are smaller automation solutions for job shops, which you can see on this photo. They're equipped with 10 pallets. Each pallet is 13-inch square, and the workpiece weight is 660 limbs. Now, this one is easy to move. For operation, the automation system, you move it in front of the machine. If you don't need to have your operator access to the machine, you just push 2 buttons and you can move it easily and push it back from the operator access. Of course, we do have other solutions from robot loading system, which I don't want to take too much time on it. And we have big solutions, as you can see. Here we got a solution with 50 workpiece pallets with 800 kilograms. Now, what kind of machining parts customers can get out of these machines? These are applications for mechanical engineers, yes, applications for the tool and die industry. As you can see here, the challenge here is rough cutting as well as fine cutting, and long running times for machining. And okay, and here you can see a couple applications for the aircraft industry. Now, as you know, due to Corona, aircraft industry is pretty much down on their knees. But we feel some inquiries because the green fuel discussion helps a little bit to develop fuel engines with less consumption. And this is one of our industries we are dealing with. And this is another example, structural parts and single blades in the aircraft industry. And here we go, you can manufacture applications and workpieces for special industry, like medical industry, as you can see, and others is parts for defense industry. And here we run through reference shortlist real quick. Most of it you might know. This is very famous in US and Canada's GE, aviation, Rolls-Royce, and other aircraft companies. In Europe, you have, you might know Audi and Fraunhofer Institute, Schott and Zeiss, and last but not least, Bosch and Siemens and Herbert. Herbert is a company in the US. And now I would like to switch gears over to my lecture, New Approach Manufacturing Strategy using 5-axis simultaneous machining centers for aircraft industry applications, mechanical engineering, and automotive industry. Today, the tool machinery industry is challenged with a vast variety of demanding applications. Ambitious target specification with technical characteristics and machining processes, strategies are state of the art and required by the customers. Now, the key thing to that, to solve that challenge is configure assortments of cutting tools, define design principles of machine, and you have to have a performance of the CNC control. Now, what are these requirements from the customers? Basically, it's a broad variety of workpieces, changing lot sizes quickly, change of workpiece, milling and turning processes on one fixture setup, and last but not least, simultaneously 5-axis machining. And all these requirements are required in parallel. Now, applications like machining of carbon fiber reinforced plastic, from aluminum alloys up to titanium, and other hard machining materials like Inconel and nickel basic alloys are required. And in addition to that, rough cutting and finishing processes with high surface qualities are the set objectives. Now, let me give you an example here. Several manufacturing locations throughout the world are required by customers. For instance, one location in Europe and another one in US or in Canada. Identical products are being manufactured. These companies require streamlined technologies. Now, what are these key performance indicators for these applications? It's accuracy, it's reproducibility, it's productivity as the essential characteristic of a machining center. You might ask yourself the question, what ingredients does a machine have to have in order to pursue these requirements? First and foremost, it's the dynamic capability. Second, it's the thermal symmetry at the tool center point. And finally, it's the rigidity of the machine body. Now, let me go into detail a little bit for you. The selection of the material for the machine body is fundamental. The base for rigidity, and finally, the damping characteristics is the key criteria for successful design concept. Now, basically, there are 3 materials machine tool builders are using for their machines, and one is welded designs of machine bodies, polymeric concrete machine frames, cast iron machine bodies, and components. Now, welded designs are not suitable due to its poor rigidity and its low damping characteristics, so we don't pursue this further. Polymeric concrete solutions may deliver benefits due to less manufacturing costs, but for highly productive machining centers, there are some disadvantages, especially in case of high dynamic load in the machine and bigger machine bodies. Now, last but not least, cast iron or ductile iron are the ideal material for dynamic stressed components with all its positive technical characteristics like 5-fold higher E model and 6 to 13-fold higher tensile strengths and compressing strengths. And this is seen as the first choice. Now, why is that? Cast iron especially is delivering both stiffness and damping values, which are direct correlating with each other. Lifetime cycles of cutting tools are affiliated to the milling process, and basically what you benefit from is you can get a 30% of increase of total lifetime of your cutting tools. Now, in summary, it is accepted that great cast iron machine bodies absorb vibrations best and endorse higher dynamical load and damping, and so influencing cutting tool lifetime significantly. Now, why do I mention that? That's because we talk about cost saving here. And cost saving, most of companies purchasing machine tools are asking first question regarding the price. Now, cost saving is more than just purchasing a machine tool. If you consider you would save 30% of tools in your lifetime, and an ALZMETALL machine can be used for 10 years, three shifts easily. So if you imagine that you can save 30% of your tool consumption, then I guess it is convincing that you can find out the cost saving is not only down to the investment, the purchasing price, it's more than the cost saving you can get through the process. And the good thing is you are using this cost saving day by day. Now let's switch gears to the technical machine design concept after talking material of machine components. Now, state-of-the-art machine design is a specific gantry design. I guess you know what a gantry design looks like, as you can see on the photo on the right-hand side. Now, gantry design itself, it's not the win. It's actually the box-in-box system within this specific gantry designs. And how do you benefit from that by using this kind of design? X and Y axis delivering absolute thermal symmetry behavior at the machining process. And you might ask yourself the question, yeah, what does it mean? What does it deliver for me? And here I would step in and would like to compare real quick standard gantry designs, which you can see on the right-hand sketch, in ALZMETALL specific gantry design, which you can see on the left-hand side. Now, standard gantry designs, if you see the sidewalls of machining centers, you have two linear guideways on which the gantry carriage is mounted. Now, it delivers you a deviation, as you can see in red, which is significant. Now, ALZMETALL has decided to incorporate the linear guide, the gantry within the sidewalls rather than above the sidewalls. And we are using 4 linear guideways inside the walls. And this delivers a 2.3 factor reduced deviation caused by inserted bending forces, which you generate by the application you're doing at your equipment. So this is a huge benefit when we talk accuracy for machining centers. Now, significant difference of modern design concept with gantry and box-in-box. On the right-hand side, you can see the machine base body, or what I'm talking about. On the left-hand side photo, you can see the box-in-box system, the green box within the 2 red bars, which is basically the carriage. And inside of this green box, you have the Z-axis with 4 linear guideways, as you can see from below. And what does it deliver for you? It makes sure that with the specific gantry concept in box-in-box travel system, the tool center point stays under all conditions constantly symmetric. Why is that important? The tool center point is the key where you get the accuracy on your workpiece. And why is that important? That the tool center point is always in the middle of your workpiece, of your machining process. Now, you can imagine that at the shop floor, at the daily use, machine tools are not being located mainly under air-conditioned rooms. That's maybe in the aircraft industry pretty much the standard, but not in the job shops, not in other companies under manufacturing environment. So the temperature you get into your machine by operating the machine coming from basically from 3 ends. One is if you place your machine next to a window, and you use it in the US, and in the morning you have let's say 65 Fahrenheit, and in the later afternoon you have 85 Fahrenheit. the temperature comes into from the through the window, then you will have an impact through temperature at your machining center. Now, if you do your cutting process and you're creating chips, blue chips, if you do fast cutting, high-speed milling, then these blue and hot chips will have temperature effect and at your machine body, basically at the below area at the machine table. And last but not least, the electrical drive system. This means the motors you're using at your machines generating heat as well. Now, in all cases, the impact of the tool center point are always similar if you're using this kind of machine concept, box-in-box system, where the tool center point stays always on the same condition. Now, another thing which I would like to mention, if you are interested in purchasing such vertical machining centers, please watch the Z-axis movement. If you might using 0-point clamping systems on your working table, you're gonna lose very quickly height in for your manufacturing of the workpiece. If you decide later to do automation to your machining center, then you lose space for your workpiece as well. So what I'm trying to highlight is, if you're thinking about 5-axis simultaneous machining, you should be open to workpieces and automation, and you should not limit to too short Z-axis movement. So please bear this in mind. This has an important impact. Now, the considerable gain of dynamic stiffness of the collective system delivers you extended tool lifetime. I stressed this out already earlier, and what it also provides is less position deviation. And this has to do with the accuracy of your workpiece. And what it does is it delivers the same level of acceleration and much higher contour consistency at the tool center point. And so you benefit from optimal milling and turning process behavior for long-running workpieces. I mean, some workpieces are running maybe 35 hours a week, and you may imagine that under these 35 hours during this long running time, there will be an impact on temperature, or you might lose accuracy on that, and that's exactly what I'm trying to point out. I talked about it earlier, the A-axis, the swiveling and the tilting A-axis and the rotary C-axis. Now, with ALZMETALL machine, you can purchase the option of having your rotary and tilting A-axis driven by so-called torque drives, dynamic direct drives. These torque drives are equipped with digital encoders. The torque drive system technology endorses highly oscillating dynamic axial movement, which are typically required in 5-axis simultaneous machining. Imagine you do a blisk or a single blade operation, and we're talking really high dynamic. We're not talking slow cutting feed rates. We're talking high-speed milling. And so with this equipment, torque drives, you can perform for hours highly oscillating workpieces, which you can't if you're using not torque drives, if you're using gear drives in A and C axis with warm gearing. Now you can imagine that this warm gearing, as they are mechanical components, they underlie a certain inherent wear by the mechanical wear. The key thing for the torque drives is they are maintenance free because no mechanical wear happens during the operation. And during the lifetime of your machine, this is a significant cost saving, and you should consider if this application or if this technical torque drive, this technical A-axis and C-axis benefits for you and the workpieces you manufacture. These torque drives, as I highlighted before, are crucial for blisk, impellers, and blade machining and its materials. And such processes, they cause considerable wear if mechanical rotary axes with worm gearing are being used. Now you can imagine the photo on the right-hand side where you do these double blisks. This double blisk runs from raw material to finished part with fine cutting about 36 hours. Now, 36 hours doing the same movement at the same place, you can imagine that you have wear of mechanical components without doubt. So to summarize what I'm trying to talk to you is the technical design, machine frame, the material, and the powerful CNC control are the success factors for state-of-the-art 5-axis machining centers. The customers using 5-axis simultaneous machining centers at the automotive industry, aircraft industry, die and mold, and the broad general mechanicals and chop shops and benefiting from operational availability, productivity, stable machining processes. This new approach technology concepts have become accepted worldwide and have penetrated major industries. I have thrown so much theory and physical formulas to your head. That's why I would like to show you a video underlining what I've tried to communicate it to you. And we are now showing you a video. It's actually a company in Ohio where we do a tire mold machining, and you see it now live. But please bear in mind, from the raw material to the finished parts, the reduction of machining time by using 5-axis machining strategy was at the beginning from 22 hours to 8 hours. And this is 64%. That's what I call cost saving. And please check it out. During my speech, there came a couple questions in, which I would like to answer. First question came in: purchasing ALZMETALL machines in the US and Canada. How does ALZMETALL provide service and spare parts? Questions, good questions, but pretty easy to answer, as I have shown. The US, European Machine Tools, is providing service for our equipment and have spare parts stock. And in Canada, it's Mitchell Machine Tools, as I have introduced to you before. They do the same. They have service technicians ready to go and spare parts in stock. Now, second question. Okay, then I was told no further questions can be answered due to time constraints. That's fine. If you guys out there have any more questions, please let us know. Through online, we will answer your questions straight away. And I would like to thank you very much for listening to me, and I appreciate it. And thank you, and stay healthy. Take care. Bye-bye.